We got Avogadro's number. Atoms or molecules per mole. All right. And we have 22.4 liters per mole. That is for gases. Okay. So let's do some practice questions. How many oxygen atoms are in 0.426 moles of aluminum nitrate? So, what do we do? Yeah. Okay. So what you have, what I give you is the first thing you write. So 0.426, 0.426 moles. .426, not 46. Of aluminum nitrate. I always put what it is, but I know people shortcut it. So ideally, you should put what you're talking about. So we have 0.426 moles of aluminum nitrate. Okay. What now? Okay. Well, we gotta convert moles of aluminum nitrate into molecules of aluminum nitrate. How many molecules are in a mole? Yeah. So we know that 1 mole of AlNO3 has 6.02 times 10 to the 3 molecules of aluminum nitrate. Okay, so then we know that the moles of aluminum nitrate have disappeared, and now if we just multiply those together, we'd have molecules of aluminum nitrate, but that's not what I'm asking. I'm asking for, what am I asking for? Oxygen atoms. So how many oxygen atoms are in one molecule? There's 9. So 1 molecule of AlNO3 is 9 oxygen atoms. Right? So then the molecules of AlNO3 would cancel out, and our number, the units are just oxygen atoms. What you have in the numerator all gets multiplied together. What you have in the denominator all gets multiplied together, and then you divide those at the end, but the denominator is all just 1, so it doesn't matter. So if you go 0.426 times 6.02 times 9, 2.31 times 10 to the 4? Yes? Is that the right number of sig figs? Since we're here, we might as well do it. What'd you start with? How many sig figs? 3. Yeah, so we're good. It's 3 sig figs, right? Yes? Does everybody agree? When you're multiplying, it's just the same number as essentially your initial. All right. O atoms. What? Is it? Oh, it's 24. Yeah, that would make way more sense. Yeah. Okay. Are we okay with that? That's kind of a basic question. Are we clear? You should know how to do something like that. Okay. What if I say the empirical formula is SCl2. Okay. But I should say and the molecular formula has a molar mass of, I don't have a calculator here. I need a calculator. One sec. And the molecular formula has a molar mass of 309 grams per mole. What is the molecular formula? So what do I mean when I say molecular formula versus empirical formula? The empirical formula is the lowest ratios. It just gives you the ratio of the atoms. The molecular formula is actually how many atoms of each are in it. Okay? So the first thing you do is if I give you the empirical formula, you should calculate the molar mass of the empirical formula. 1 molar mass of SCl2. Sulfur is 32.1. Just go over molar mass here. That's sulfur. Chlorine is 35, but we have 2 of them. And that gives you 103.1 peoples. 2. Two times 35.5 should be 103.1, right? Does that make sense to everybody? Okay. So then what do I do? How do I find the molecular formula? Yeah. You take the molar mass of the molecular formula, divide it by the molar mass of the empirical, and the ratio is what you multiply by. So then you go molecular divided by empirical. So I get 309 grams per mole divided by 103.1 grams per mole, which gives me basically 3. So that means you multiply the empirical formula by 3 to get the actual molecular. Therefore, the molecular is 3. This isn't real chemistry or how you would write it, but it's 3 times that. So then it's actually S3Cl6. Yeah? Does that make sense? I just made that question up, so that's not a real compound. What? No, yeah. You're given the imperial. Find that molar mass. You divide the molecular molar mass by the empirical. That gives you the ratio that you have to multiply by. So it's S3Cl6 because 6 and 3, if you reduce it down, it's 2 and 1. Okay? Oh, okay. All right. Are you good with this? You will have a question like this on your test. Okay. Percent composition. So if we have a formula C2H6O, there's our molecular formula. So what is the percent composition of each atom? What do you do? Find the molar mass. It's the first thing. molar mass. Carbon is 12, and you have 2 of them. Hydrogen is 1, and you have 6 of them. Oxygen is 16. If you do that, you get 46. That's the molar mass. Okay. Then all you do is divide the mass of each element by the molar mass. So if we're going to do carbon, how many grams of carbon are in this molar mass? 24, right? Because you have 2 carbons. So it's 24 divided by 46. It was 24 divided by 46. 52% times 100%, I guess. Okay, we're just going to round to the nearest. 52. Okay? Then you got to do oxygen. Or hydrogen, doesn't matter. Oxygen is going to be 16 divided by 46. I don't know what that is. 35 times 100. I guess I have to put that in there. It's 35%. And then you're going to do hydrogen, which is 6 divided by 46 times 100, which is, Carter, 13%. Those should all add to 100. Or close to it, depending on your rounding. But does that make sense? Okay. Oh, what if we do... Okay. What if we do the reverse? So I give you the percentages. You got to figure out the empirical. So let's go back here. An unknown has 61.4% copper, 15.4% sulfur, and 23% oxygen. 23.2% oxygen. What's the empirical formula? I guess I should write that. What is the empirical formula? What is the empirical formula? Okay, what do we do? Well, you got to do something first. You're close. That is kind of the first, sort of this first step, but there's one other thing you have to do first before you do that. Times what by the molar mass? You want to, you're going to make them numbers. What does percent mean? Per 100. So you're going to make them out of 100 grams of substance. So essentially, you're going to say you have 61.4 grams of copper. Okay? And then you're going to have 15.4 grams of sulfur and 23 grams of oxygen. But because this is chemistry, we don't want grams. We want moles. So then you multiply by the molar mass. Okay? So for copper, 1 mole is 63.5 grams. For sulfur, 1 mole is 32.1. And for oxygen, 1 mole is 16. Because then the grams cancel and you're left with moles. So we get 0.967 moles, 1.45 moles, and 0.480 moles. Okay. You are correct. Sorry. You're right. That is 0.480. And the one below is 1.45, right? I just read my key wrong. Sorry. Okay. What do we do now? Divide by the what? The smallest number is what you divide by. Okay, so the smallest number here is 0.48. So you divide everything by the smallest. Oh. Come on. Okay, so the smallest number is 0.48. So I divide 0.48. So 0.967 divided by 0.48 is 2.01. That's going to be 1. And this is going to be 3.02. Okay. They're not always perfect because it depends how you round, but they should be pretty close, like 0.02 and 0.01. That's close enough. So that means we have, for copper, Cu2, I have 1 sulfur, and I have 3 oxygens. Cu2SO3. Copper sulfite. Copper 1 sulfite.
Wait, if it was like 0.25, would you have to?
Yeah, you would have to make it a nice, but that's like a quarter, a half, things like that are okay because they're easy to deal with.
Okay.
But you're not going to get like 0.13 and stuff like that. Okay. If it's 1.25, you'd multiply by 4. All right. Okay. Is that okay? All right. That's sort of the mole. You want me to do stoic? Or do you want some time to practice? Stoic? Okay. Let me stop this. I'm going to make a separate video.